Welcome. We are today continuing Centroid G for a triangle continued. This is part 2. Now, before I go continue part 2, I will give a small recap. See, last class what happened. See, I'll tell you here. This is actually what is last class. And then very powerful note is there. 1 minute. If you go through all my classes, you can observe one thing. So many concepts I repeatedly tell. What is the reason? So by repeated telling, you will understand better and it will remain firm in the mind. You should see what amount of effort I am putting. You can see now. This is already over. I have seen so many places. They get the answer, mark it, and that's all. Go to next part. No. I want you to thoroughly, but I thought of telling, I want to thoroughly understand. No, not I want to thoroughly understand. I want you to thoroughly understand. Okay, now see, last class, triangle in general. See here, base B, height H, or turn it here, base B, height H. If this is the base, vertex. If this is the base, vertex. Now, this is a triangle in general, means what? This distance is not equal to this distance. So let it be, see, in the base B, there are two parts are here. One side is B1, one side B2 here. See, which is bigger, which is smaller, does not matter now. It matters later, I will tell you. Same way, along the base, one of them is B1, other is B2. So now, I will take the point as A here, point as B here. C is the vertex, see here. I will take the point A here, point B here. C is the vertex. C is the vertex, okay. Now, what we got last time is centroid for a triangle in general. The expression is, see, remember now, it is either 1/3, it is either 1/3, 1/3 or 2/3. See, some people tell 1/3. No, 1/3 is wrong. Either tell 1/3 or 1/3. Either tell 2/3 or 2/3. Like x square. Some people tell x power square. No, it is not x power square. Either you tell x square or tell x power 2. Okay, does not matter. So, it is either 1/3 or 2/3. See, something I am telling, of height. Of height. This is, you should write, measured 1/3 or 2/3. See, 1 minute here. Third, measured along the height. Very important. Measured along the height. That is, answer is 1/3 of height or 2/3 of height. Measured along the height means measured from base. See, measured this way means measured from here. This is all I told earlier. See, measured from along the height. If you measured along the height, you are measuring from base. Measuring either from base or vertex. See, this way measurement. See, now, if you measure from base, centroid, see, some will ask, sir, why you put that side? Okay, I know that. See, B1 more or B2 more, it counts later. But in this sketch, I wrote B2 more. So CG will always lie, centroid will always lie on that side where area is more. After everything is over, there will be a thorough explanation. There I will tell. So anyway, our important is this distance, not this distance. See, along the height, 1/3 of h from base or from vertex, 2/3 of h, both are along the height. Or if you turn here, see, vertex, 1/3 h this way or 2/3 h this way, measured along the height. So now I will tell you, you write it 100 times. Very, very, very important class regarding 1/3 or 2/3. See, 1/3 or 2/3 you have to use only when you measure along the height. For that, a base and height should be defined. See here. Here, yes, if you call this as base, height is defined. Same way here. If you call this as base, height is defined. But now, if see this way, if this is the base, you can't take the base. See, you cannot take a base here. There is no base here. So here, along, see, this way, if you want to locate CG, there is no height. See, this is the base, this is the height. This is the base, this is the height. So now, this much is I explained last time. See, 1/3 and 2/3 you use only when you measure the distance along the height. There should be a proper base, a base and height. See, if the base is like this, height is like this, or then 1/3, 2/3 along the height. If the base is this way, this is the height, 1/3, 2/3. Okay. Now, 1/3 from the base, 2/3 from vertex, or very simple. See, centroid will come near this side, why more area. This is near to base, see, 1/3 here, 2/3 here, near this side. If I turn, it will become near that side. Okay, leave it now. Now, how to locate centroid G along the base? See, along the base. That is, see, I once again wrote here. This is the base, this is the height. These are along the height. See, these two are along the height. Along height. Right. Already over. See here, already over. So I put right mark here. Already over, already over. Here. See, this distance. This is the base, this height. So these two are along the height. Along the height. Already over. That's why don't bother now. This is already over. Now, how to locate CG along the base, not along the height? That means, see, I marked CG here. See, CG here. What is this distance? And what is this distance? See, 1 minute now. Here, this will be Y bar. I can tell Y bar from, see, this is a Y bar from, I won't call A here. Yeah, okay, this is not required. See, this here, this is your Y bar. This also is your Y bar. This is Y bar from base. Y bar from a horizontal line, if you draw here, from vertex. Already over. Here, see. This is, these two are X bars. These two are X bars. You can write here. This is X bar from, once again, from base, X bar, measured along height. This is X bar from vertex, this way. Now the problem is, here, see, this way is known, see, base, height, this way is known. What about this way? That is, if the centroid is here, what is this distance? What is this distance? Or, if centroid is here, see, this way is known. Why? 1/3, 2/3. What about this distance and this distance? So, as per this sketch, this will be X bar. I can tell X bar from A. This is X bar from B. A means you imagine a light reference line here. See, actually, okay, perpendicularly measure. X bar from A will do. See, X bar measured along the base from A. X bar measured along the base from B. Both are X bars. Now, these two, this we have to get. This we have to get. For this, remember, no 1/3, 2/3. No 1/3 or 2/3. Remember, 2/3, nothing, because this is not a height. See, there is no base here. This is not height. Same way here. See, these two are no 1/3, 2/3. No 1/3 or 2/3. I told you, nothing. Separate formula is there. I will get that one. So now I will locate CG for a triangle in general measured along the base. I will go for this case. I can go for any one sketch. I will use this one. what answer I got for this sketch, same, see, that what answer I get this distance here, see, this distance and this distance, that you can use for y bar here. See, what I got x bar here will be y bar here. Why? Here base is this way, here base is this way. This much explained. If people still don't understand or lazy, so that they do not go to the entire class, everything, if they don't go, they are losing. And one thing, yesterday's class, somewhere, see, integration of dA, integration of second law, I wrote dA into y was there. There, our dA was b dash into dy. Okay, then I substituted there integration of some b dash into, by mistake, I wrote dA and then y. Actually, when you write dA in terms of b dash, dA equal to b dash into dy, it is not dA, it should be dy. That is called oversight. It is not a mistake, oversight. Anyway, next step I wrote once again dy only. So otherwise someone will comment, how it is dA? No, I wrote, so replace dA by b dash into dy, then the dA will change over to dy. I by mistake, oversight, I see what happened is, as I write suddenly dA, I forgot, not forgot, suddenly by accidentally I wrote dA, but later next step I wrote dy only. In the comment section and description I wrote it. In the description I wrote, see at some timing I given 42.4, 42 minutes, 43 seconds I think, I don't remember. There is a small correction. I wrote it in the description and also in the comments. I commented there. My comment, you can see there. Comment by case and structure engineering classes. My comment it is. Okay. Now over. Now I will go for this one. See, I will go for this case or this case. See, I don't have to find both. If I find this distance, that will be from B, you subtract it. That's all. One of them I will do. Here also, same thing. If I get one distance, other you can get. So, now I am going for location of centroid along the base. See, along the base. 1/3, 2/3 will not work out. Along the base for a triangle in general. Okay. Now, see, class starts from here. Don't see that side. Location of centroid G along the base for a triangle in general. See, let B be the base, H be the height. You write here, from the vertex, if you drop a perpendicular to the base along the height, let one side, see, this total base is B, let one side be B1, other side is B2. So I will call the point here A, B, C, I will call this as D. See, I will call the point as D. Now, we want x bar from either this side, from that side or this side. We will go for x bar from A. Okay, right here. This is centroidal distance along the base from left side. See, x bar from A, that is x bar from B. Once you get x bar from A, x bar from B will be B minus x bar from A. Okay, now, right here, we will find x bar from A. Therefore, make a note. Okay, this over no formula. Therefore, as per principle of integration, x bar from A means actually from a reference vertical line here. Anyway, no problem. X bar from A will be equal to integration of, same color once again, dA into x divided by total area. Total area is integration of dA, not required. I told already 1,000 times. This is integration of dA. Okay. Now, where dA is area of elemental strip, where dA is area of elemental strip and x is distance of that strip from reference point. Very important. From reference point. Very, very important. From reference point. From where reference point with respect to, write a reference point with respect to which you are finding x bar, that is here from x. Here your x should be from A. See, that is here. Since you want x bar from A, your x should be from A. From A. X is green color. Okay. X is green color, other is red color or black color. Okay. X should be from A. Very, very important. From A. Okay. This is a formula. Now I am removing all this one. See what I am. See correctly what I will do. Now one small note you can write. Basic. Option 1 we are doing by, see I told option 1 basic, that is you write here. This is option 1, that is basic, that is by integration. I forgot to tell you. See, one option is, I forgot to tell earlier, you get x bar from here or there, we'll find x bar, you write here. See, we'll do from option 1 basic, that is by integration principle. Then, see, full base is b. One of them is b1, other is b2. No, use only one of them. Too many variables become difficulty. So, use b here and b1 here. Actually, I know that for x bar from A, b and b1 required. For x bar from b, b and b2 required. Anyway, that you will be knowing later. So, this is b, this is b1. If you want, you can write b2. But remember, b2 equal to b minus b1. So, once it is b1, dotted line, I will write b minus b1. I want only two variables, b and b1. Otherwise, b will come, b1 will come, b2 will come. Answer will come. Okay, now, one note in the class. This is quite lengthy. Quite lengthy. Helpless. Because when you take a strip here, single strip you can't cover. See, it goes this way and turns here. So, A to D, you have to take a strip, and one more strip you have to take from D to B. Two strips are required. So, little going to be lengthy, but we are going for basic. I will write the expression etc. fully, then I will start. Okay, now this is by integration principle I am doing. You make a note. There is another option which is very, 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 very easy that you can do. Suppose examination, if they ask the question somewhere or to understand, the option 2 is much, much better. No complication, nothing. But I always believe when I teach, everything to be taught. Those who are not serious can do one thing, just to go through this one, see the option 2 correctly. Okay, now this I will remove because I want space. Some writings are there. We will find x bar from here over. Formula is already there. Okay, it's all over. See now. You put this sketch. See now. Consider, see, first make a note. Since A to C, A to D, the height keeps on increasing, then again it decreases. Therefore, single variation you can't do. See, this height, the strip, as you go here, strip height will keep on increasing. Height or width, no problem. This B is not that B. This is B dash. B dash means width of strip. Okay. Or I can call H dash also if you want. If you want, you can call height H dash also. Okay. Okay, I think H dash is better. Okay, H dash is better. Height H dash. H dash, that is much better. H dash here. Instead of B dash, this is called H double dash. Okay, H double dash. Now see, this is H, height H dash, H double dash. Make a note, 2 sections required. Therefore, right, between A and D, one strip, and again between D and B, first strip and second strip. You write that much. Okay, now write. Consider elemental strip of thickness, very important. When you want x bar, thickness should be dx. 1000 times I told. Thickness dx at x from A, and this is between A and D. Or I can write here, right here. Between A and D, much better. Right here. Between A and D, consider elemental strip of thickness dx, x. Let h dash be height of that strip. That strip. 1 minute. Check the camera. I have gone too much upper side. Hope it's not gone. Okay, no problem. Okay. H dash be height of the strip. Now see. Then I told you should get H dash in terms of x. From similar triangles, see here. H dash divided by x. This, if it is not clear, don't come to my class. H dash divided by x equal to, see here, H dash by, see here, see this triangle. H dash by x equal to h divided by b1 equal to h divided by b1. Therefore, your h dash will become h by b1 into x. This is h dash. Next, therefore, elemental area, that is dA only, no dA1, dA2. That also, see, this also area equal to dA, this also area equal to dA. Everywhere area is dA only, elemental area dA for that strip equal to h dash into dx. H dash into dx or equal to h dash. H dash is h by b1 into x into dx is your dA. Okay, over. Elementary. Now, same way. Now, consider, now, next, between D and B, consider elemental strip of thickness. Once again, dx only, remember, don't take something else. When you take distance x, this thickness dx, one more dx, at x from same point. You cannot change it now. When you want x bar from A, x from A. Then let h double dash, okay, h double dash be height of that strip. This strip. Therefore, now, see, get h double dash with respect to x. See here, again from similar triangles. See, correct, clear? Now you should stand here only. H double dash divided by this distance. See here, when this is x, this distance is, you should know, total is b, this is x, this is b minus x. Therefore, h double dash divided by b minus x, your h double dash divided by b minus x equal to h, see, this side by this side equal to h divided by b minus b1. H divided by b minus b1. Therefore, your h double dash equal to h divided by b minus b1 into b minus x. b minus x. And same way, therefore, elemental area dA equal to what? h double dash into dx, or equal to h double dash h divided by b minus b1 into b minus x. This is b minus x. This is dA into dx. dA equal to, this is the answer for dA. See, this is your dA. Second dA, this is your first dA over. Actually, now I need not see there. I will write the answer here. I will remove all this one. I will write the formula here. Therefore, see now one more thing. Limit of integration. I will tell briefly here. For the first between A and D, x is for this strip and this strip both, x is from A to D. Starting point of x is 0, ending point of the strip is at B1. So for this one, x varies from 0 to B1. See, for this strip, x varies from, I'll put here now if you want, x varies from first one, 0 to B1. This is very easy to understand. But second one, your x varies from, see here, from here to here. X is from here. See, the limit is always lower limit. Later, I will upload one more class for in YouTube for this limit problem, not for this subject. Entire engineering. Whenever you want to decide the limit, lower limit is always distance of starting point. Upper limit is always distance of ending point from the origin. Origin means from where you considered x. For both the, you should write it, for both the strips, x considered from A. So for this strip, lower limit is, see, A is the starting point. Distance of A from A, 0. And upper limit, distance of D from A is B1. For this strip, it lies between D to B1. Now I want to cover D to B1. See, once again, start D. Lower limit, distance of D from A, B1. 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 B1 to ending point, distance of B from A, that is B, full B. So for the first one, limit is 0 to B1, second is B1 to B. Or for example, see, it is simple. I will give explanation with the journey in the YouTube. Simple language. I don't know where you came from or which place, I don't know. See, suppose you are in some place I require, Bombay, in between, I don't know which station comes. I don't know which station will come in between. No. Okay, I will tell in YouTube only later. Suppose you want to have a journey, for example, okay, but if I tell local Karnataka, okay, I will tell you here. See, those who are in Karnataka, this is Bangalore. Bangalore. Somewhere here it is Mysore. Single journey means Bangalore to Mysore, flight. But in case a bus journey or a train journey, there is an intermediate stop here. A stop is called Mandya. Those who are North Karnataka, North Indians, all outside, remember Mandya. Mandya is very famous for political reasons. Okay. Journey is Bangalore to Mandya and Mandya to Mysore. So, Bangalore to Mandya, first journey. Then, not from Bangalore to Mysore, Bangalore to Mandya and Mandya to Mysore. That way you have to remember. So, this, but there I will tell some other example. I will give a beautiful example there and make clear. In that YouTube class, I will see that limit for integration you require for strain energy method, etc. I will give a very thorough explanation so that later in the structural analysis, whenever limit comes, I will directly write limit 0 to 3, 3 to 7, 7 to 10. Somebody will ask, sir, not clear. Not clear means go to that class where in the YouTube, exclusively I told, you cannot be so lazy. If you are studying from me, everything I upload, study. See, sorry, I am a strict person. If you want to learn from me, study everything I tell. Wrong things I will not tell. Okay, now I will remove this one now. I write somewhere here now. See. Okay. Therefore, final answer. See. Therefore, conclusion is x bar from A. I am rubbing everything now. From A equal to. I told formula is what? Integration. I told already there. See. Integration of dA into x is. Okay. Okay, I'll write this. I remember. I'll write here. You write here. Therefore, right. X bar. Don't write that one now. X bar from A equal to integration 0 to B1. See, just now I told of first area. H by B1 into X into yesterday by mistake in one place I wrote dA, it should be dx into dx, green color. X is the variable into dx plus integration B1 to B, second integration, B1 to B of, sorry, so forgotten. This is dA, dA into X is there. Into X, forgot X, okay, into X plus integration B1 to B of second area, H by B minus B1 into B minus X, B minus X into dx. This is your dA, see, this is your dA. This dA into x complete divided by total area. Don't waste time. Total area, don't integrate, is equal to half into base into height. See, for a triangle, don't waste time for integration. Total area, that is A1 plus A2 is, or you can write half into, see, you can write this area is half into B1 into H plus half into B minus B1 into H. Simplify, it will become half into B into H. Okay. Now, therefore, you should write below. I am writing above because I am removing. I want this one. Therefore, see, once again I will write here x bar from A equal to integration 0 to B1 of, see, first I'll do one thing. I'll take constant outside. Okay. Take constant outside. B by H by B1, constant outside. H by B1 integration 0 to B1 of x square dx, x square dx plus integration B1 to B of, if a camera is not working, I'll check it now. Take outside. Oh, sorry, first constant outside. H by B minus B1, constant outside, into this side you can't take outside, integration of B1 to B of bracket B minus x times, oh no, B minus x into x is there. Oh, see here, B into x, oh, forgotten. Okay, B into x minus x square dx, x square dx dx. Then actually you should write somewhere here, because then see, divided by total area, that is equal to half into base into height. Okay, this is your x bar from A equal to over. Now I will tell you one thing. I can leave this for you. You can do the integration. I will tell you my guarantee, 100%, my guarantee, answer is x bar from A will come B plus B1 divided by 3. This is my guarantee. Then I will explain. This is the answer. If you integrate this one, simplify, you will get x bar from A equal to B, yes, correct, B plus B1. This 3 is not that 3. This is not 1/3 height, etc. B plus B1 by 3 is the answer. Okay, now I will start fresh now. So this is the one you have to integrate. Now, I wrote the expression. I first thought, let me not do the integration. Leave it for you. Those who are serious can do it and get the answer. Because there is an easy option after this one, very simple option. So I thought first, no, leave it for you. Then it came to my mind, maybe some people may tell, oh, maybe he got difficulty for integration. No, I have no difficulty for integration. My mathematical concept is quite good. Today, if at all I am in this level, it is because of the understanding of the basic mathematics. So my mathematics will never let me down. Therefore, then I decided, okay, do it. Okay, better do it. And for your information, this is the first time in my life that I am getting this result by integration principle, because reason is there. When I teach for academic, all this more than around 40 years, I go for easy option. I do not want to confuse the students by complications. Nobody wants it. And when I teach structural engineering subject, design aspects all, there I don't derive the formula. These formulas understood. I will tell you studied in your engineering. Therefore, first time I am doing it. One thing, I am not what you can call is little tensed or what I am having confusion, not confusion, nothing like that. I am fully free. I know that answer will come. Okay, I will do it now. Okay, start. That's why I wrote numerator here. That much I wrote in front of you. Remaining I will do in front of you only. Okay, equal to, here. Numerator I am doing equal to h by b1 into x square becomes x cube by 3, 0 to b1 plus h by b minus b1 times bracket b into x becomes x square by 2. These all I can't explain. X square by 2, and then minus x square becomes x cube by 3. X cube by 3. For this, see, correct, h by b minus b1, b x square by 2. Limit is, again, not limit, b1 to b, or equal to, see, h by b1 into x cube by 3 becomes, now green color is not required now. Why? Integration over. See. b1 cube by 3 minus 0 is this term plus, see, h by b minus b1 times b into small bracket, see, small bracket here, x square by 2. X square by 2 will become x cube by 3, that is b cube by 3 minus b1 cube by 3, this term is over, minus again bracket, x cube by 3, upper limit, b power 4 by 4, it is b power 4 by 4, anywhere term cancels, b here, one b comes here, 1 minute, b power 4 came, b power 4 by 4 minus, see, minus lower limit, b1, oh sorry, why b1 power 4, already integration over, see, already integrate, x square becomes x cube by 3, it is already, see, sometimes such mistakes happen. I thought integration is not over. Integration is over. Therefore, x cube by 3 is b1 cube by 3, h by b minus b1 into b square by 2. See, sometimes this is called oversight, minus b1 square by 3 minus, see, x cube means actually what happens is usually I don't write this way. If it is x cube, I directly write, see, suppose you see x square is there. I directly write x cube by 3 and put the limit. I don't write in future all that way. So first to the mind what came, oh, x cube is there, becomes x power 4 by 4. No, already integration over. Therefore, b into b square by 2 minus b square by 2 minus b1 square, see, minus b1 square by 2 minus lower limit, x cube by 3 is b cube by 3 minus b1 cube by 3. Okay, everything is over. Sometime it happens, or equal to, see, b1 cube by b1 is h into b1 square, cancels here, plus h by b minus b1, sorry, h into b1 square by 3, okay, by 3, plus h by b minus b1 into b square is b cube by 2 minus, I will put b first, b into b1 square by 3 minus b cube by 3 minus plus, why, minus of minus plus, plus b1 cube by 3, b1 cube by 3, correct? b cube, 1 minute, h by b minus b1, one small mistake means problem will come, b into b square is b cube by 2 minus b into b1 square by 3, why 3 and 2 came here? No, it is not 3 and 2. This is actually 2. Oh, see here. When you substitute x square by 2, upper limit b square by 2 minus b1 square by 2. I am seeing that number. See, actually here b into x square by 2 is b square by 2 minus b1 square by 2. Here minus b cube, x cube by 3 is b cube by 3 minus b1 cube by 3. See, sometimes such small mistakes, it will spoil everything. So it is h by b1, h by b1 cube by b1 is b1 square, h b1 square by 3 plus h by b minus b1 into b square, b cube by 2 minus b into b1 square by 2, then minus b cube by 3 plus b1 cube by 3 is the answer, or equal to, see, h by, this will be equal to h into b1 square by 3 plus h by b minus b1 into, see here, b cube by 2 minus b cube by 3. 1 by 2 minus 1 by 3, you should know mathematics, that is 1 by 6. b cube by 6, see, 1 by 2 minus 1 by 3 is 1 by 6, I am sure, minus this term over b1 square by 2 plus b1 cube by 3. Or now what I want is, see, now what I want is, I want a common denominator. See, here 3, here b minus b1. Somewhere here 6 is there, 2 is there, 3 is there. I want complete common, denominator should vanish. So I will take h, see, h will remain as it is. I will change the pen, the ink is fading, okay. h, this color is not right, okay. This is h, outside I am taking, for 3, 6, 2, 3, I am taking 6 outside, and also I am taking b minus b1 outside times, see here, h by 3 is there, so 2 will come here, 2 b1 square into b minus b1. b minus b1. Why? I am taking common denominator, b minus b1. See here, 3, I am taking 6 here, so 2 will come here. 2 by 6 is 1 by 3 into b minus b1 plus b minus b1 has gone outside, h gone outside. In place of 6 is there, so 6 means it will become b cube, that's all, only b cube. Only b cube, because 6 has gone here, h by b minus b1 outside, so b cube minus 2 is there, 6 outside, 3 what? b1 square, 3b b1 square plus 3b b1 square plus b1 cube plus or minus 1 minute, plus minus plus, correct, plus here 3 is there, so 2, is it correct? See here 3 is there, how it came 2 here? Yes, this 2, correct, no? This has gone outside, these 2 cancelled, there is 2 here, 3 here. I think it's correct. One small mistake, everything is gone. b cube by 6, correct. These 2 terms are over. b cube by 6 minus b1 square by 2 plus b1 cube by 3, correct. Okay, now 6 outside is, this is over, b2, when I take outside, here see, 2 b1 square into b minus b1, correct, and then plus b minus b1 has got out 6 outside, 2 is there, so why only b cube? Why only b cube here? No, it is not only b cube. This is correct, this term, b cube over, okay, 6. Here, b1 by 2 is there, means 3. 3, correct. Then here, plus, here 3 is there, so 2, which one? b1 cube. 2 b1 cube. Anything wrong? I am getting doubt about this one. b1 square into b1 square into b cube. 2b cube plus 3b cube. 1b cube here, 2b cube. Sign problem is there anywhere? Because if one sign mistake is there, everything is gone. Plus 2b1 cube plus 2b1 square. Okay, done. Or I will continue here now. Equal to, okay, h by, see, sometime it happens, h by 6 into b minus b1 into, see, 2b1 square into b. So 2b1 square. I will write 2b1 square. I will write b first. 2b1 square minus 2b1 cube minus 2b1 cube. Which one? This one. Then plus b cube. Plus b cube. That b cube I got doubt. Okay, b cube correct. Plus b cube and then plus b cube over then minus 3b1 square minus 3b1 square 3b1 square 3b1 square and then 2b1 square minus 2b1 cube plus b cube. How that b cube came without any multiplying? Okay, upper limit. Minus 3b1 square plus 2b1 cube plus 2b1 cube or equal to h by 6 into b minus b1 times, see here, minus 2, red color I will use, just to understand, minus 2b1 cube plus 2b1 cube, these two will cancel. So what you are left with? b cube, then 2b1 square minus 3b1 square is minus b1 square. Correct, I think, most probably. This will cancel. 2b1 square plus 2b1 square, b cube is over, plus 2b1 square minus 3b1 square is minus b1 square. Okay, over. Or equal to, anything cancels here? I can take now b outside here, see, or equal to b h divided by 6 into b minus b1 into b square minus b1 square. Yes, we got the answer. Answer came. Or equal to, see now. Yes, now I told my mathematics will never let me down. Frankly, I am telling, in my life, first time I am doing the integration. But I got confidence. But see, such places, how I got the answer, you will know now. See, one small mistake here in sign or multiplying, it will go somewhere else, completely out of control. That happens to everybody. See, human being, when you write something or some simplification, sometimes it happens, mistake. But it is not technical mistake. I told in my class throughout, technical mistake. I will not come tomorrow and tell me, yesterday, see, I told this concept, that is not correct, it is wrong. See, yesterday I told you, you should subtract it. No, you should add it today. Or yesterday I told you, divide by. Today I will tell, sorry, it is multiplied by. Or yesterday I will tell, it should be taken positive. No, sorry, it should be negative. That mistake I will never make. Okay. Or equal to BH by 6 into B minus B1 into B square minus B1 square. You can write B plus B1 into B minus B1. You should know that much mathematics. A square minus B square is A plus B into A minus B. Now, B minus B1 cancels, or your numerator is how much? BH by 6 into B plus B1 is the numerator. And denominator is nothing but area. Don't integrate. You know area is half into base into height. Therefore, x bar from A equal to numerator BH by 6 into B plus B1 divided by area is BH by 2 are equal to, therefore, equal to B cancels, H cancels, 2 will go to numerator, 2 1 by 3 equal to answer B plus B1 divided by 3. This is the answer for X bar we got. B plus B1 by 3. See, I told X bar will come B plus B1 by 3. Okay, done. So, I got the answer. You can see me, I am not tensed. When I was doing this calculation, some places I had doubt. One small mistake in sign is gone case. Okay, now this is, remember, right here, what we have done is what is little lengthy. Actually, it is the basic, that is by integration. Now I will go for easiest method or simple way of getting the X bar. Then I will put summary. Most probably class is becoming lengthy. I will get the result by another aspect. I will close today's class. Tomorrow I will give full summary including some example for loading. When I took earlier, I will tell you afterwards. Set up the board. So my answer is still there. Make a note. This is our question in discussion. See? This is our question in discussion. We want to locate centroid along the base, X bar from A or X bar from B. Along the height, you know it, 1/3 and 2/3, you know it. Just now we got X bar from A, B plus B1 by 3 by basic, that is integration, of course, little lengthy. Now go to shortcut, easy method. Now go to easy method. You don't have to struggle that much. Easy method. Now, one note you have to make. Option 2, very, very easy. See, I will tell something. Divide the given triangle in general. In general means not right angle, randomly, general, into 2 right angle triangles. Right angle triangles as shown. See here, as shown. 2 right angle triangles. This will become B1. This will become H. This will become B2. Now we will take this as figure number 1, this as figure number 2. We are going for now summation principle. That summation, if you remember, A1x1, A2x2, that way. Now, for that one, you want this area is A1. This area is A2. Area you can get half into B1 into H, half into B2 into H. But you require x1, x2. See, this centroid is here. Centroid is here. Now, see correctly. Centroid you can locate directly by 1/3 or 2/3 of height, provided there is a base and height defined. Earlier, see, this is the base, this is the height. This way, base and height is not there. But this time, see here, for right angle triangle, in my next class, I am explaining this one. So if you got difficulty, you go to next class, study and come back. See here. For a right angle triangle here, see, for triangle number 1, this way, if this is the base, this becomes height. Or if height, same way, for the triangle, see. If this becomes the base, this becomes height, because for this one, this is perpendicular, for this one, this is perpendicular. So, now you imagine this is the base. This is the base for both. So, this way for this base, for both triangle, This will be height. This also will be height. Therefore, centroid will be from vertex here 2 by 3 of B1. This will be 1 by 3 of B1. And from here to here is 1 by 3 of B2. This will be 2 by 3 of B2. Or how to decide, I will tell you. Centroid will always lie on that side where there is more area. Tomorrow I will tell you. So this triangle, more area this side. CG will be, centroid will be near to this point. It is far away from vertex. See, far away from vertex here. Near to the base, far away from vertex. Anyway, if any confusion is there for this one, you see tomorrow's class or next class. Next class is summary class. I will tell you very, very, very powerful, not only for centroid, but also that uniformly varying load. Some what all I told earlier, tomorrow I'll give recap for you so that in future you have no difficulty in your life for when uniformly varying load will come. Okay, now I will remove this one. This all over. Okay, I won't clean too much. Okay, I am feeling already tired. But little should be clean. Should be little clean. I hope that answer will come now. Today I will get the answer and stop the class. Summary tomorrow. Okay, now see. Little time for getting dry. Wet means the ink will not flow correctly. Okay, start. Divide into two parts. See here. One smaller, one bigger. Which smaller, which bigger does not matter. This is the triangle. See here. This is your B1. This is your B2. See, right angle triangle. This is your height H. This is your figure number 1. This is figure number 2. This is one of the area. This is other area. This centroid, see, if I take base here, along height, centroid is here, G1. This centroid is somewhere here, G2. See, from here, from the base, smaller distance, 1/3 of P1. This is 2/3 of B1. And here, this is 1/3 of B2. This is 2/3 of B2. This all I will explain tomorrow once again. Total height is length is B. Okay, start. Now, you measure X from here. See, you want X bar. We are doing X bar from A. See right here. We are finding X bar from A. Then formula is A1x1 plus A2x2 divided by total area. This is the formula. Okay, start. Total area, don't waste time, is A1 plus A2 or directly equal to half into base into height. Or if you want, see, somebody will be laughing for you. This area, half into B1 into H. One more area, half into B2 into H. Or half into B1 plus B2 into H. B1 plus B2 is B, half into B into H. Somebody will tell, what is this? For a triangle, when full base is known, you don't know how to find area. That also you are splitting. See, for x1, x2 you are split. So area is half into base into height. Now, see, x you are measuring this way. See, this is how you measure x. Because why? Because x bar from A we want. So equal to A1. Okay, I'll do one thing now. I'll do only numerator now. Only numerator. Okay. To save the time. Your numerator is A1x1 plus A2x2. See correctly now. Equal to A1. Area of this figure number 1. Half into B1 into H. A1, this area, into its centroid from here, 2/3 of B1 into 2 by 3 of B1 plus area of figure number 2, half into B2 into H into its centroid G2 from here we want. So don't see this one now. It is B1 plus 1/3 of B2. B1 plus 1/3 of B2 or equal to, see here, half into, half comes outside, half into, okay, I will do one thing now, or equal to half, okay, half that will be outside because in denominator also half is there. So don't spoil that half. Half into B1 into H into B1 to B, you can do one thing. You can take half and also, see, H outside. Half into H you can take outside. So when you take half into H outside, B1 into 2 by 3 B1 is 2 by 3 B1 square plus half H by 2 you are taking out in plus B1 B2, correct? Half into H outside, B1 B2 plus, I am taking half outside here, plus, where is it? Half H, B2 into B2 plus B2 square divided by 3. B2 into B2 is B2 square into divided by 3. B2 square divided by B2 into B2 square. H by 2 has gone outside. Okay. B2 square divided by 3 or equal to 1 by 2H into, take common denominator, 6 common denominator. If I take 3 common denominator, why 6? 3 common denominator. If I take 2B1 square plus 3B1 B2 plus B2 square by 3 or equal to H by 6 into, see, 2B1 square. There is a B1 square here, there is a B2 square here, and B1 B2 is there. We want in the format of A plus B whole square, what I will write is 2B1 square, I will write B1 square plus, instead of 3B1 B2, I will put 2B1 B2 plus B2 square. Now what is pending now? 2B1 square is there, one taken, next plus B1 square plus 3B1 B2, 1 already over, 2 already over, plus B1 B2. Simple. This 3 you make 2 and 1, this 2 you make 1 and 1 or equal to H by 6 into, see, B1 square plus 2B1 B2 plus B2 square is equal to B1 plus B2 whole square, okay, or equal to H by 6 into B1 plus B2 whole square plus B1 square plus B1 B2. But we know that equal to H by 6, right here, we know that B1 plus B2 equal to B. See here, B1 plus B2 equal to full base B. H by 6 into B square plus B1 square plus B1 B2 or equal to, see, H by 6 into B square plus, from here take B1 outside. B1 outside. If you take B1 outside, B1 plus B2. B1 plus B2 or equal to H by 6 into B square plus B1 plus B2 equal to B plus B into B1. Or you can tell, you can take B outside, it is BH by 6. Why? B outside into B plus B1. B plus B1 is the numerator. Okay. Now, lastly, denominator. Okay, I will remove the sketch now. Unwanted, all over. Okay, I am closing now. Time also is not there. Now, therefore, x bar from A equal to numerator is how much? BH by 6 into B plus B1 divided by denominator is half into base into height. Half into base into height. BB cancels. H cancels. This 2 will go to numerator or equal to x bar from A equal to or x bar from A equal to B plus B1 divided by 6 will come down, 2 will go there, divided by 3. Oh, right here. Oh, that is the same answer we got by basic principle. Okay, now I will close the class by writing one more term. This is x bar from A. Now, what about x bar from B? You don't have to waste time. Therefore, you can tell once you get x bar from A is how much you got? See, this is the sketch. This full is B. This full is B. From A, centroid, we got, this is your x bar from A. We got, see that sketch, B plus B1 divided by 3. This will be your x bar from B. This is A, this is B. This is B. Okay, x bar from B. Therefore, x bar from B equal to total is B minus B plus B1 by 3 or equal to 3B minus B minus B1. 3B minus B minus B1 is 2B minus B1. 2B minus B1 or equal to, I want to B2 now. 2B, I will do one thing now. 2B, I will put B plus B minus B1. Divided by 3, I forgot. Okay. Divided by 3. Okay, I forgot the divided by 3 only. Divided by 3. But, or equal to B plus B minus B1 divided by 3. But B minus B1 equal to, this is B, this is B1, B minus B1 is B2. Therefore, x bar from B equal to B plus B2 by 3. B plus B2 by 3 for both integration answer. In both, first you got x bar from A, this is valid for integration also. See, or concluding part of today's class will be, if there is a triangle in general, this way and this way, if this is height h, this is b, base, along the base dotted line, the split distances are little bigger, I want little bigger. Okay. This is the base B. Base B. See, if I project here, this is your B1, this is your B2. Centroid will be here, G. Why this side? Tomorrow I will tell. If you want height wise, see, this is 1 by 3 of H. This is 2 by 3 of H. From top, if you come 2 by 3, here 1 by 3. Whereas, if you want to locate the centroid, from here, it will be full base B plus this cut length B1 divided by 3. B1 divided by 3. Whereas if you want from here, it is full base B plus this cut length B2 divided by 3 sufficient. Furthermore, and thorough explanation and application for structural engineering when uniformly varying load is there, that all I will tell tomorrow. That is concluding part of centroid for triangle part 3. Tomorrow full I will give you thorough explanation for triangle in general, isosceles triangle already over without knowing, and right angle triangle, and also remind you about the application done. Thank you. Thoroughly go through. This is already cited.